Have you ever wondered how scientists design experiments to figure out what causes what? It all comes down to two key players, the independent and dependent variables. Understanding them is like having a secret decoder ring 4 scientific studies, making it much easier to understand everything from how plants grow to why certain medications work. Simply put, the independent variable is the one thing you change or control in an experiment, and the dependent variable is the thing you observe or measure, which is expected to change in response. Think of it as a cause and effect relationship, where the independent variable is the cause and the dependent variable is the effect. The core idea here is to isolate the impact of one specific factor. Scientists want to know if changing X directly leads to a change in Y. To do this effectively, they keep everything else constant, so they can be confident that any observed change in the dependent variable is truly due to their manipulation of the independent variable, and not something else entirely. So how do you spot them in action? Imagine you are testing if the amount of fertilizer affects plant growth. The amount of fertilizer you give each plant is your independent variable, because you are controlling and changing that specific factor. Then, the plant growth, which could be its height or the number of leaves, is your dependent variable, because you are measuring how it responds to the fertilizer. This concept is fundamental to scientific inquiry, whether you are examining how temperature influences reaction speed or how study time impacts GED scores. A good way to remember it is that the independent variable is what you, the experimenter, change, and the dependent variable depends on that change. It is the core of forming a testable hypothesis, allowing researchers to draw clear, evidence-based conclusions. Mastering the distinction between these two variables empowers you to not only understand scientific reports better, but also to think critically about cause and effect in everyday situations. This skill is crucial for interpreting data, designing your own investigations, and ultimately, excelling on your GED science exam, where you will encounter many scenarios requiring this exact understanding.